Okay, this method will not work for all the problems, but this method is a more universal method of solving such quadratic equation. Okay, let us come to the mostly in this you will find all the quadratic equations have been solved by middle term factorization or factorization of trinomials. Consider this: 4x square plus 15 is equal to 16x. Okay, first we write it in the form ax square plus bx plus c, which is not in this form. This form is not ax square plus bx plus c. So we write this in the form ax square plus bx plus c is equal to 0 by taking all the expressions, all the terms to the left hand side. So I write 4x square plus 15 minus 16x is equal to 0. Okay, so I make the right hand side 0. Now what happens? I want to write this in the form ax square plus bx plus c. So this is my a, x square minus 16x. So b is my minus 16 plus c. C is my plus 14. So if I write it in this way, what you must see is that a here is 4, b here is minus 16, and c here is 15. Okay. Now we proceed to solve this quadratic equation by middle term factorization. Okay. So let's see if you can break the middle term. 15 into 4 is 60. And 60, what are the factors of 60? 1 and 60, 2 and 30, 4 and 15, which will not give you minus 16, obviously, all these. Okay. Next is 5 and 12, 6 and 10. Yes, 6 and 10 will give me minus 16 if I take minus 10 and minus 6. So you break minus 16x as minus 10x because I have a minus 10 here, and minus 6x because I have a minus 6 there, plus 15 is equal to 0. Okay, so group the terms, first and second. You can do directly also, no problem. Group the third and the fourth. This sign has been changed from plus to a minus sign because I have kept a minus sign here. So now we take the HCF of the first and the second term. HCF is 2x, 2x minus 5, minus HCF of 6 and 15 is 3. So 2x minus 5 equal to 0. So we are getting a common factor here, which is 2x minus 5. And therefore, I can take out the common factor 2x minus 5. So I'm only left with a plus 2x and a minus 3. So this means when the product of two numbers is 0, that means either of them has to be 0. That means either 2x minus 5 is equal to 0 or 2x minus 3 is equal to 0. That means either x is equal to 5 by 2 or x is equal to 3 by 2. Okay. So what are the roots of this equation? The roots of this equation are 5 by 2 and minus 3 by 2. Okay. Any doubts?
No, sir.
No, sir.
No, sir.
I think quadratic equations is not a big deal unless if you know the middle term factorization, if you know factorization by identities, you can do middle term factorization. I mean, you can solve the quadratic equation. So first, let us now consider 7(1). We have 4x square plus 4x plus 1 is equal to 0. Now, if this expression, mostly the expressions can be factorized by middle term factorization. If they are not, if you cannot solve by middle term factorization, you will try out the identities. Okay, you will try out identities. Now see, if I suppose if I try out middle term factorization here, let's say if it works out, 4 into 1 is 4, so 4x square plus 2x plus 2x plus 1. That means 2x into 2x plus 1, and the HCF of 2x plus 1, I'm grouping these two together, this and this together, plus 1, HCF of 2x and 1 is 1, is equal to 0. That means it becomes 2x plus 1 into 2x plus 1. So even if you don't realize that the you have to use a plus b whole square or a minus b whole square, you can use middle term factorization. Okay, so that means 2x plus 1 is equal to 0. That means x is equal to minus half. So therefore the roots of the equation are x is equal to minus half and minus half, two coincident or equal roots. Now what you see here is something that is very important, which I think I may have mentioned in the last class also, that if a quadratic equation has equal roots, just like in this, see that this left hand side of the equation can be expressed as a perfect square. Okay, this is a very important observation, that whenever you have equal roots, any quadratic equation can be expressed as the left hand side of the quadratic equation can be expressed as a perfect square. See that in this has been expressed as, this entire expression has been expressed as 2x plus 1 whole square. This indicates that the quadratic equation will have equal roots. Okay, I have mentioned that in my note here also, two equal roots. Okay, now look at this problem, x minus 4 whole square. Please mute your audios. X minus 4 whole square plus 5 square is equal to 13 square. Okay, now see, you can always expand, just as in method 2 I have shown you. Okay, okay, so you can always expand and do this. That is, I expand by a minus b whole square formula, e square minus 2ab plus b square plus 25. 5 square is 25, equal to 169. That means x square minus 8x plus 16 plus 25 is equal to 169. X square minus 8x plus 41 is equal to 169. Now you write it in the form ax square plus bx plus c, ax square plus bx, which is minus 8x, and c is 41 minus 169 equal to 0. That means x square minus 8x, and you subtract, you get minus 128 is equal to 0. Okay, now you break it up as x square. 128 can be broken up as minus 16 and 8. Minus 16x plus 8x minus 128 is equal to 0. Means group the first and the second, group the third and the fourth. Now take the HCF. Now you take out the common factor, x minus 16. That means either x minus 16 is equal to 0 or x plus 8 is equal to 0. Means either x is equal to 16 or x is equal to minus 8. Okay. Now we have got the two roots of this equation as x is equal to 16 and x is equal to minus 8. Now see this, in this method I have actually squared and brought it to the form ax square plus bx plus c. But in method 1, see what I did. In method 1, what I have did is, what I have done here is that I have taken um, this 5 square to the uh, right hand side, and then I have taken the square root of resulting 12 square. Why did I do this? The point is that you must realize you have done Pythagorean triplets. You know that uh, 12, 5 and 13 is a Pythagoras triplet, right? And you see a 5 square here and you see a 13 square here. That means of the only one that is missing is 12. That means if I take 13 square minus 5 square, I'm definitely going to get a 12 square, right? So that is why I have solved this method. This method is not a universal method because obviously you'll have to look for here 5, 12 and 13 was a Pythagoras triplet, which I realized and hence I solved. But in most of the cases, it will not turn out to be a Pythagorean triplet. Okay, so I would recommend this normal method that I have done here. Okay, look at this, 3x minus 8 by x is equal to 2. Now see, first we are going to remove all the fractions. So we take the LCM. LCM is x, and here we have a 1. It just becomes 3x square minus 8 is equal to 2. Now we cross multiply, 3x square minus 8 is equal to 2x. Now you make the right hand side 0. So 3x square minus 8 minus 2x is equal to 0. Now you express it in the form ax square plus bx plus c. Ax square plus bx plus c. So what are the values of the coefficient? If you compare with ax square plus bx plus c equal to 0, what do you get? You get a is equal to 3, you get b is equal to minus 2, and you get c is equal to minus 8. This realization is very important because quadratic equation is one topic that will be continuing for class 10 also. Okay, so you must check the coefficients. A is equal to 3, b is minus 2, and not plus 2 but minus 2, and c is minus 8. Okay, so now we are going to simply factorize this. 8 into 3 is 24. Let us factorize 24 into two factors. Okay, so we have 1 and 24, 2 and 12. Okay, 3 and 8. Yeah, 4 and 6. So 4 and 6 will give you minus 2, minus 6 and plus 4. So 3x square minus 6x plus 4x minus 8 is equal to 0. Now I group the terms, 3x square minus 6x, first and second, third and fourth. I've kept a minus sign outside, where I've kept a plus sign outside, so this sign does not change. Okay, so now we take the HCF. 3x square and 6x HCF is 3x, get x minus 2, and 4x and 8 HCF is 4. Take out 4, you get x minus 2 is equal to 0. That means you have x minus 2 into 3x plus 4 is equal to 0. That means either x minus 2 is equal to 0. First factor, either first factor is equal to 0 or the second factor is equal to 0. Means either x is equal to 2 or x is equal to minus 4 by 3. So the roots of the equation are x is equal to 2 and minus 4 by 3. Okay, any questions? Any particular sum that you want me to work out from anywhere? I've worked out all the sums I think in this exercise.
Sir,
Yes,
so from compound interest, question number 29.
I will come to compound interest when I'll discuss compound interest. For the time being,
Yes,
we are
sir.
discussing quadratic equations. Any question from quadratic equations?
Sir, 11 part 1.
This one,
Yes, sir, yes.
x minus 1 by x plus 1 is equal to 2x minus 5 by 3x minus 7. So whenever you see such expressions, put brackets. Even if the brackets are not given, you put brackets, cross multiply. And my first aim is to bring this to the form ax square plus bx plus c. That is what I'm working towards right now. So cross multiplying, and then you multiply 3x square minus 7x minus 3x plus 7 is equal to 2x square minus 5x plus 2x minus 5. Simplify the left and the right hand side. 3x square minus 10x plus 7, 2x square minus 3x minus 5. Now you make the right hand. Mute your audios, please. Now you make the right hand side 0. 3x square minus 2x square, bringing 2x square from the right hand side to the left hand side, minus 10x, again bringing minus 3x from the right hand side to the left hand side, and bringing minus 5 from the right hand side to the left hand side. Okay, so this will become x square minus 10 and plus 3 is minus 7, and so brought it to the form ax square plus bx plus c. Any doubts here?
No, sir. No doubt.
No, sir.
Now we try the middle term factorization. Okay, so what are the factors? 1 and 12, 2 and 6, 3 and 4. 3 and 4 will work. X square minus 3x minus 4x plus 12 is equal to 0. Group the terms. X square minus 3x, first and second, third and fourth, keeping a minus sign outside. The sign within the bracket is going to change. X into x minus 3, okay, minus HCF of 4x and 12 is simply 4. Then x minus 3 equal to 0. That means x minus 3 into x minus 4 is equal to 0.
Sir, in the bracket it will be plus because minus sign is introduced.
Yes, sir.
Yes, sir.
I could not get you. Yes, say again. Yes, say again. What were you saying?
So I'm
Sir, it
saying
will
that
be
minus 4 is outside the bracket, so the sign will change. No.
Yes, but
yes, sir.
since
It
I
will be x.
see, I have already grouped here. I have already
No, it's
changed the
correct.
sign here. I have already changed the
Yeah,
sign
it's
here.
correct.
So now
Yes,
I
sir, it
don't
is
need to
changed.
change the sign here. I am simply taking out the HCF. If you are doing directly, then you will have to do that. X into x minus 3. If you're not grouping here, if you're not doing this step, okay, then x into x
Oh,
minus 3, then you take a minus 4 and then change the sign within. Okay, understood? So
okay.
I'm just adding one step here of grouping. Okay, that is why. What you are saying I have already done in this step. Okay, so that means
Yes.
either x minus 3 is equal to 0 or x minus 4 is equal to 0. Mute your audios, please. How many times do I have to tell you? Only when you're speaking, you unmute. means either x is equal to 3 or x is equal to 4. So that means the roots of the equation are 3 and 4 only. Any doubts? Any particular step?
No, sir.
No, sir.
No, sir.
Look at this. 8.
Excuse me.
Yes, you want to say something?
So can you do 12 part 2?
12 part 2.
Yes, sir. Can you
12 part
do?
1 is clear.
Yes, sir. Yes, sir.
Okay, 12 part 2. Okay, so I have x by x plus 1 plus x plus 1 by x is equal to 2 1 by 6, a mixed fraction. Take the LCM. LCM will be product of the denominators, x into x plus 1. Okay, now here you see you have x plus 1. How do you what do you do? What you do is from the LCM you divide x plus 1, isn't it? Suppose I have to take the LCM of 2 by 3 and half. What do we actually do? See, LCM is 6, 3 and 2. Now what do? You divide 6 by 3, isn't it, to get 2. Now you multiply this, sorry. Now you multiply this 2 with this 2, isn't it? To get a 4
Yes,
here,
sir. Yes.
No.
to get a 4 here,
Hmm.
isn't it? Now
Yes.
I have taken an x into x plus 1 as my LCM. So in order to get what should I multiply with this x? This one. Is that clear?
Yes, sir.
Yes,
So
sir.
what do we have to multiply? We simply have to multiply this x with this x. So I have x into x. Now is it clear?
Yes, sir.
So now
Yes, sir.
for this,
Yes, excellent.
what do you have to multiply with x plus 1? X into x plus 1
X plus.
divided by x, isn't it? So you simply have
Hmm.
to multiply x plus 1.
X
This x plus
plus
1
1.
has to be multiplied with this x plus 1. So x plus 1 into x plus 1
X plus 1.
is equal to
Whole square.
13 by 6. Right? Let me just erase
Hmm.
this. Use a different color. Okay, so I have x square plus x plus 1 whole square by x square plus x is equal to 13 by 6. Now you cross multiply. Or let me first simplify the left hand side, then I'll cross multiply. So you have x square plus, we maintain the brackets, I will open the brackets later. X square plus 2x plus 1 divided by x square plus x is equal to 13 by 6. Yes, simplify, open the brackets, x square. This is a good habit actually. You can do it directly, no problem, but this is a good habit because brackets are there. You have to, because if there's a minus sign with a bracket, then you are quite prone to make mistakes. So therefore,
Okay,
it is a good,
sir.
always a good sign. I mean, always a good habit to open the brackets and then simplify, whether it is a plus or a minus sign.
Okay, sir.
Uh, okay, so I've simplified the left hand side. Now I cross multiply. Okay. 12x square plus 12x plus 6. 13x square plus 13x Now you make the right hand side 0. 12x square minus 13x square plus 12x minus 13x plus 6 is equal to 0. Minus x square minus x
minus x
plus 6.
plus 6.
Okay. Now you can factorize directly, or what you can do is you can take the minus common. Minus with an x square does not look good in a quadratic equation. You can work with this also, no problem. But since minus with an x square does not look good in a quadratic equation, we would like to make it a positive sign. So you take the minus common, x square plus x minus 6.
Plus x minus 6.
That means this becomes x square plus x minus 6 is
Plus
equal to
x
0.
minus 6.
Now you can break the middle term, 2 and 3, right? Or no, minus plus 5 and minus 1. Oh, 2 and 3.
3x
Should be plus 5x
Plus 5x
plus
minus
3x
x.
plus
minus 2x.
3x minus 2x
Yes. Now you group it.
Plus 6. Plus 6. Okay.
Now you take the HCF. X square and 3x.
X
HCF
plus
is x
3.
minus twice of x
X
plus
plus 3.
equal to 0. That means x
Hmm.
plus 3 into x minus 2 is equal to 0.
0.
Means either x plus 3 is equal to 0 or x minus 2 is equal to 0.
0.
That means either x is equal to minus 3 or x is equal to 2. So therefore the roots of the equation are minus 3 and 2. Okay.
And 2.
So this is what now one special problem. I've got only 1 minute left. Okay, so I'll finish this in the next session. Okay.
Okay.